Hello guys, thanks for coming back again. For those that have subscribed, if you are yet to subscribe, please click on the subscribe button and also on the bell beside it to notify you when we drop a new video. In this video, we want to prove that the gamma function of 1 over 2 is equal to square root of pi. So how do we go about proving that? So let's see how we can perform the magic. So now to prove that, by the definition of gamma function, the gamma function of x plus 1 is equals to the integral of 0 to infinity of e raised to power minus this, which this symbol means beta, dot this raised to power x dx. So that's the definition for gamma function. So how can I continue from here? So mean this, what is here is this. So now let this be equals to st. If that is equals to st, then what will happen? Then I say the integral will be transformed. Don't forget db is here, so d is going to give us s dt. So putting that back into the integral, what am I going to have? I'm going to have the gamma function of x plus 1 is equals to integral of 0 to infinity of e raised to power this becomes st, that's minus st dot, then don't forget this is st, so I put it st all raised to power x, then db equals s dt. Now we can proceed from here. This is the same thing as rearranging and evaluating what is here. We have 0 to infinity of e raised to power minus st, then x raised to power x dot t raised to power x dot s dt. Can you see this? So from which I evaluate and multiply the t together. So this gives me integral of e raised to power minus st, then this s with s gives me x raised to power x plus 1, then t raised to power s dot dt. Are you getting that? Are you following? So now let's see. The next one is integral of, don't forget, 0 to infinity of, then I rearrange. If I bring this x raised to power x plus t out, I'm going to have x raised to power x plus t integral of e raised to power minus st, then t raised to power x dot dt. Don't forget 0 to infinity. So with what I have here, this has taken me to Laplace, because the Laplace transformation of t raised to power x is given by this. So meaning that I can say the gamma function of x plus 1 is equals to x raised to power x plus 1 multiplied by the Laplace transform of t raised to power x. So that is what I have. So meaning what is here becomes the Laplace transform of this. So from there, I can actually say that the Laplace transform of t raised to power x is the same thing as the gamma function of x plus 1 all over s raised to power x plus 1. So this is the statement. So from there, I go ahead and evaluate the Laplace transform of this. So how do I evaluate? Then taking this left hand side, that's left hand side, which is the Laplace transform of t raised to power x, which is equals to what I have here. 0 to infinity of e raised to power minus st t raised to power x dot the t. So then I have to evaluate this Laplace transform. So we can substitute there and actually continue the proof. So on doing that, to evaluate this, then let's x equals minus 1 over 2. If x is minus 1 over 2, what would happen? What would have happened to the function? So from there, anyway, we're going to have t raised to, let's take it from here. So if this is 1, and we know that the Laplace transform is divided by this, so we call that 2. So if we take s to be minus half, then it's going to affect this. So meaning I'm going to have the Laplace transform of this is going to be t raised to power minus half, all equals to, then I have the gamma function of, this becomes minus half plus 1 gives us half, all over this becomes minus half plus 1 gives us s raised to power minus half, sorry, s raised to power half, just like this. So now, meaning to evaluate the Laplace transform of t raised to power s, I am evaluating the Laplace transform of t raised to power minus half. So that is what it implies. So meaning I'm going to evaluate the Laplace transform of t raised to power minus half, which is the same thing as integral of 0 to infinity of e raised to power minus st dot, then we have t raised to power minus half. We have the t. So from there, we can continue. Sorry, excuse me. So let's continue from there. Let's continue from there to evaluate this. So to evaluate this now, don't forget we have a formula which we have to stay tuned to. So that is this. Don't let us forget. So that's L raised to the power L. The Laplace transform of t raised to the power minus half is equals to the gamma function of pi of 1 over 2, I mean, all over x raised to the power half. So we need to note this equation because we're going to use it later. So now let's proceed to evaluate the Laplace transform of this. So to evaluate that, I will say let's y squared equals st. If y squared equals st, meaning that t is going to be equals to y squared all over x. Take that all from here. So meaning to differentiate these two sides, I'm going to have, this is an implicit differentiation. So I'm going to have 2y the y equals s the t. So from there, the t becomes 2y the y all over x. So if I substitute all this back into this integral, I'm going to have integral of 0 to infinity e raised to the power minus y squared as st is 1 dot, then t becomes y squared over s, so I have y squared over s all raised to the power minus half dot, the t becomes 2y the y over x. So evaluating all we have here, I'm going to have, bring this out, is going to give us 2 all over s raised to the power 3 all over 2. That is what it gives. So from there, I'm going to have integral of 0 to infinity e raised to the power minus y squared to y. So after evaluating what is here with this is what it gives. So they move out of the integral, then we have this. So now from there, let's continue. So from there, it is known that the integral of 0 to infinity of e raised to the power minus y squared dy is the same thing as half root of pi. It gets half root of pi, so it has a proof. But anyway, don't let us prove that now because we are meant to just prove that this is this. So to cut long story short, so how do we cut the long story short? Now this is half of pi. So meaning we're going to have what is here is going to become 2 all over x raised to the power 3 over 2 multiplied by half of pi. So meaning this goes with this. Definitely I'm going to have what? Root of pi all over x raised to the power 3 all over 2. So meaning the evaluation of the Laplace transformation of t raised to the power half gives us this. So bringing it here, I'm going to have what? A Laplace transform of t raised to the power minus half, which is equals to the gamma function of pi of half, x raised to the power all over s raised to the power half, now becomes root of pi all over s raised to the power 3 over 2, all equals the gamma function of half all over s raised to the power half. So comparing the numerator, if you compare the numerator, what will you see? If you compare the numerator, you see that the gamma function of half is the same thing as square root of pi. So if we compare the numerator here, we discover that root of pi is the same thing as the gamma function of half. Root. Thanks for watching. Please subscribe to our YouTube channel. It's free. Thank you.